I want to create a video just to review a few concepts that are very simple but can get very confusing. And this one has to do with average rate of change versus average value. And it can be confusing because when they ask the questions, both questions are going to have the word average. And so sometimes it's not easy to figure out what they want you to do. So here's a function p of t, which equals e to the 0.2 t, and it measures the height of a plant in inches, and t is measured in days. Question, find the average rate of change of p of t for the time 0 to 5. And then the other question is, find the average height of the plant on the interval 0 to 5. So again, if you are not careful, it sounds like they're asking for the same thing. Definitely both of them use the word average, and that can be quite confusing. The first thing to realize is if they want you to find the average rate of change, then they'll have to spell it out, average rate of change. So that's something they'll have to do. And on the other hand, when they want you to find the average value, you'll notice that here they don't use the word value, they've replaced value with height. But there's a reason for that. When you think about the height is given by p of t, so this is like saying find the average of p of t. Moreover, p of t is a y, and in math, when we use the word value, if it doesn't explicitly say x value, then the word value means y. So when we say average value, we mean the average of the y, or in this case the average of p of t, or the average height. That's why they've replaced the word value with height. And if they said average value, then a lot of students understand what formula to use for it. So just know that many times they'll leave out the word value, but they'll replace it with the units of the y or the function itself. So if this had been velocity, they would have said average velocity. If this is, what else could it be? Growth, then they would say average growth. And so keep that in mind. So going back to question 1, find the average rate of change. What do you need to know about average rate of change? When they say average rate of change, that is as opposed to instantaneous rate of change. Now we know the instantaneous rate of change would be the derivative. And so the average rate of change is not as good as the derivative, but it's still a slope. The average rate of change would be the slope of the secant line. Slope of the secant line. And the derivative, which is the instantaneous rate of change, that is the slope of the tangent line. And so the secant line is quite easy to get because this is the slope from Algebra 1. And back in Algebra 1, they told you that to find the slope, you take the rise over the run, or delta y over delta x. That's supposed to say delta x. Delta y over delta x. And that's exactly what we're going to do here. Take the y's on the numerator, subtract them, and then divide by the difference in the x's. And so then we have the interval from 0 to 5, so we are going to try p of 5. We start with the last value, minus p of 0, divided by 5 minus 0. And if this is the AP test, then you should know that this is already giving you 1 point, just for writing the quotient. If you don't have the quotient, you lose that point, and there's a chance you get no points even for having the right answer. If it's free response, you have to show where you're getting your answers from. This is worth a point, writing out the quotient. And then you would say, well, this is equal to p of 5. Well, plug in a 5, e to the 0.2 times 5. 2 times 5 is 10, 0.2 gives it a decimal place, and so it's just e to the 1. and e to the 1 is just e. Can't do, there it is, minus, and then 0, plug in a 0, 0.2 times 0, 0, e to the 0. And then that divided by 5. You don't have to simplify if it's free response. This could be your answer. There's nothing wrong with this answer. So if you're not comfortable reducing, then leave it this way. But you should know that this is just e minus e to the first is 1, e to the 0 is 1 divided by 5. And the other thing I'm leaving out are units. You have to have units. To get the units, just think of it as what are the units of the numerator, what are the units of the denominator. The numerator is p of t, and p of t was measured in inches. So this is inches in the numerator. And then the denominator, 5 minus 0, those are times, and time is measured in days. And it's a division of them, so it's inches per day. This is the average rate of change of the plant in inches per day. And that would be the answer. Now let's talk about the next one, which is and by the way, that gets you the other point, having the right answer. Now number 2, find the average height of the plant on the interval 0 to 5. We just discussed that this means average value, and that many times they leave out the word value, but you know by saying height that they want you to take p of t. So then that means we use the formula for average value, which is 1 over b minus a times the integral from a to b of whatever thing you want the average value of. In this case, we want the average height. So then it's the integral from a to b of p of t dt. So that would be 1 over 5 minus 0 times the integral from 0 to 5 of e to the 0.2t dt. Okay, so that'll be 1/5 integral from 0 to 5, or actually let's go ahead and take that integral. And some of you also have been forgetting how to take integrals like this, which is pretty simple. E to a power, how do you integrate e to a power? It's e to the same power, 0.2t, divided by the derivative of the power, 0.2. This is called the chain rule in reverse, because if you were taking the derivative, you would say e to the same power times the derivative of the power. But here, since you're taking the antiderivative, then you take the chain rule in reverse. Instead of multiplying by the derivative of the power, you divide by the derivative of the power, and then you evaluate that from 0 to 5. And so we have 1/5 times top minus bottom. So e to the 0.2 times 5, that's going to be e to the 1 again, or just e over 0.2, and then minus e to the 0.2 times 0, that would be e to the 0, which is 1, and then over 0.2, okay? And we can actually, because we have the same denominator, then we can say that this is 1/5 times e minus 1 divided by 0.2. And when we multiply, we can multiply these two fractions, the top times the top, the bottom times the bottom, and we will actually get 1 times e minus 1 is just e minus 1. And then 5 times 0.2, that's going to be just 1. So it's e minus 1 over 1, or just e minus 1. Now the units here, the units are a bit different. It's not going to be the same units as the average rate of change. What are we looking for? The question says, find the average height. So if you're looking for the average height, it has to have the same units as height itself, which are inches. And so the units of this is in inches. E minus 1 inches. Another way you can tell what the units are is if you take this apart, take the integral and say, there are three components here, 1 over b minus a, p of t, and d of t. Each of those three components has units. What are the units of 1 over b minus a? The 1 has no units, but the b minus a is the time difference, and it was measured in days. P of t is measured in inches, and d of t is a very small amount of time, and even though it's very small, it's still measured in days. And so then you can see that when you take these days and you divide by these days, they'll cancel out, and the only thing left is inches. And this is the formula we used for average value. So then when you do take the integral, whatever answer you get should be in inches. You can always do this dimensional analysis to figure out what the units are. Now, you should not try to make any connections between these two results and say something like, hey, look, it's e minus 1, and then try to come up with like some sort of rule saying, well, this is only being divided by 5, so the only difference between these two is that the average rate of change gets to be divided by 5. That is not true. The fact that these two answers sort of look the same is a pure coincidence, and it has something to do with the fact that the integral of e to a power is e to the same power. But if this was a different function, those two results would look different, way different. So please don't try to link the two. There is no relationship between these two. This is the slope of the secant line. And to recap, if you want to find the slope of the secant line, they have to say, find the average rate of change. And on the other hand, if you want the average value, many times they are going to hide the word value from you, and instead they're going to use the function's units, or whatever the function stands for. So average height, average p of t, and because p of t is a y, then this is average value. Another observation is that something that happens a lot is when people evaluate average value, they somehow forget the 1 over b minus a part of it. Maybe because it's at the beginning, or I don't know, but when you rewrite the lines or when you show your work, make sure you keep on writing the 1 over b minus a part of it. One way to help you not forget is you should always work at the problems vertically downward. Don't go sideways and say this equals that equals the other. Because if you go sideways, just trust me, your chances of forgetting that 1/5 are higher than if you just go vertical. Because when you go vertically down, you can already see if things are missing or not. For your eyes, this is a very easy movement, up and down, but going from here all the way to the beginning, it's not something you usually do. So always show your work downward, and on the AP exam, you'll have plenty of room to show work. So try not to go sideways. Even something like this, I myself messed up. I should have maybe gone downward. If it's small, if it's a short amount of work that you need to show, then I guess it's okay to go horizontal. But my preference would be go vertical. Now, here's an interesting example. It says g of x is equal to 3x squared plus 2x, and it gives you the rate of fuel consumed by an engine in gallons per minute. And then the question says, find the average rate of fuel consumption on 0 to 4. And this can be so confusing to some students because of the wording again. They're using the word average rate of fuel consumption. And so students get fixated on this average rate, and they say, well, it sounds like average rate of change. It must be this formula here. But what you have to keep in mind is that they're usually not going to say the word value, even if it's an average value type question. What you need to remember is, okay, hold on. G of x is measured in gallons per minute. that means that g of x is a rate function. They even told you so. They said this gives the rate of fuel consumed by the engine. So basically then, when they say average rate of fuel consumption, that expression, all of it can be replaced by g of x, because g of x represents the rate of fuel consumption. And so then in essence they're saying find the average of g of x. And g of x happens to be a y value. It's actually the collection of all y values. So this question, even though it says average rate, it didn't say average rate of change of g of x. It said average rate of fuel consumption. And there's a difference. It didn't specifically say average rate of change of g of x. And I hope you can see then that this is an average value question, because you can replace what I underlined by g of x. So they want the average of g of x, which happens to be y values. So then this becomes 1 over 4 minus 0 times the integral from 0 to 4 of the function g of x, which was 3x to the second plus 2x with respect to x. Maybe we should put parentheses there. And you just work out the problem and get an answer for that. And again, make sure you can distinguish between finding an average rate of change and an average value. If you integrate, that's just x cubed, and then this is 2x squared over 2, or just x squared. And we're going to evaluate from 0 to 4. So that'll be 1/4 my pen is not functioning properly. 1/4, and let's see, the 4 will give you 4 times 4 times 4, that is 64, plus 4 times 4 is 16. That's the upper limit. When you replace 0 for the lower limit, you're going to get 0 on both of those. And so we have 1/4 times 64 plus 16, which is 80. And 80 divided by 4 is 20. And what about the units? The units. Well, what are the units of this? This is 1 over 0 to 4, which are the x values. The x values are miles. And then these are also miles here. They're going to cancel out. You just end up with the units of the integrand, just like the last example. Whatever units the integrand has, those are the units that remain, because dx units and 1 over b minus a units are going to cancel out. And what was the units for 3x squared plus 2x? That was measured in gallons per mile, because this is fuel consumption. And if you want to get the average rate of fuel consumption, it has to have the same units of gallons per minute. Okay? So don't be misled, even if they use the word average rate. If it didn't specifically say average rate of change, then maybe it is average value. Check the function and see what the function is measuring, and that'll give you a better idea of whether to use the average rate of change formula or the average value formula.